Okay, so in this test we're going to get set up to do the Poisson's ratio experiment. These are on flat bars. And there should be an axial gauge and a transverse gauge. So we see up here the axial gauge, and then this one here should be the transverse gauge. And they're both hooked up as a 3-wire quarter bridge. You'll need the flat specimen jaws in here. Okay, so you need to change them out from the round, if you just did the tension test, into the flat bars on the top and on the bottom. You'll need a strain indicator. Now on the cover of the strain indicator is the wiring schematic for the 3-wire quarter bridge. That should be this one right here. And if we take a look at that closely, there are 3 wires. One goes to P+, one goes to S-, and these are 120 ohm gauges, so the other wire that's on the common terminal goes to D120. Now the way I wire mine up, if I can find the specimen there, I usually try to wire my circuit up where we have red on one side and black and white is the common terminal. Okay, so here there's a little wire going to one, and then there's another wire going to the other side. This is a terminal strip, and the common node is the black and the white. So that means over here on this box, the white wire can go to, over here on this side, the white wire can go to S-, and the black wire can go to D120, or it really doesn't matter. The black and the white can go either way. But the red wire, that's the single node, that'll go to the P+ position over here. On your strain indicator, of course, you got the power button. It'll boot up. You need to select the bridge type. Okay, and so now this says it's a half bridge, but what we want to do is we want to, well, it's on channel 1 is a half bridge, but this is hooked up to channels 3 and 4. So 3 and 4 are quarter bridge, and that's great. That's just what we want. We want those on quarter bridge. The gauge factor. Oops, go back. The gauge factor should be written on the specimen somewhere.
1.2.
Or it may be in the lab manual.
Yeah.
That's the lab manual. Okay. So yeah, look in the lab manual. So they're usually around 2.1 or something like that. 2.07. Yeah. So that can be adjusted in here. Now let's see. That's on channel 1. So let's go to channel 3. Okay, 2.07. And that one says 2.08, but you can change that to 2.07 if you like. And the units they're going to read in microstrain. So when the students see these numbers, they need to understand that that's 10 to the minus 6 automatically. Okay. So you hook up the wires, you'll mount the specimen, and then you'll balance the bridge by hitting the balance button. It's going to ask you to hit it again. Make sure you want to balance it. I'll go through and balance the Wheatstone bridge. Channel 1's not hooked up. It's going to complain. Channel 2's not hooked up. And then we'll hit the record button to save the information. And so those should read as 0. Now, why don't you pull up on this a little bit? Just put some tensile force on it. Okay, so one of the gauges should read positive and the other should read negative. So it looks like channel 4 must be the tensile axis, and gauge 3 must be the transverse direction. And so what they'll do is they'll take measurements at several different loads, and then they'll measure the strains and then try to compute the Poisson's ratio as the ratio of those two. So Ham, how did you load it? Did you manually just load it?
Yes.
Okay. So when this testing machine's turned on, then you can just adjust the position with this until you get to the load level that you'd like.